Hi guys, so it's 1:48 a.m. and uh, we still work on this layout, and our objective here is basically we want to build a ring oscillator. So it's actually an analog device which allows synchronization of the digital circuit, right? And this is our circuit here schematic, and actually this is not the whole circuit. You can see there are so many transistors here. This is the top level we call sorry the inside hierarchy, and the top level is like this. Let me check. 50 megahertz. This one is the top level. Yeah, you can see over here. So we have the whole device we call ring oscillator, and this one you can see the main inverter. Here we have three inverters plus one two three four inverter outsides, right? All right, so this is actually five stage. So this is four stage, this separate inverters plus this one whole block, so five, right? And we have the this is the biasing devices for, yeah, to bias the circuit, right? And yeah, this is actually the unfinished layout. So I'm still doing I'm doing the what we call the floor plan. So I want to fit it inside this square. You can see the blue square here. Actually, yeah, we want to make it as square as possible because, yeah, we want to save more spaces and to ensure that uh, we can minimize the black area. So we want to fit it in such that the black area is minimized, and yeah, we call it the black area is basically the dead space. We want to minimize the dead space. And yeah, I already finished the connection of this, the biasing circuit. This is the biasing circuit. I've do the, we call it routing. So routing is actually you connect the drain, source and gates of the transistors. Yeah, I finished this pretty much, but the hurdle is actually this one. The five stage here, the three stage here. This device is actually the main. Yeah, it's quite painful because it's you see so many things you can see here, and of course I will expect complex connections here. So I hope, yeah, I do not uh, misconnect or, yeah, do some mistakes. Otherwise, I will redo everything back. So that's why the first thing we need to consider is basically before you do any kind of connections, you need to check whether the placement. So actually, the placement of the transistor is very important in layout design. What I mean is basically in layout design, we need to consider the matching properties, right? So we want to make sure that all of the devices follow the matching rule. What is matching rule? Matching rule is basically we want to make sure that our transistor, all of them, are matched, okay, with as our desired in our schematic, right? So we want to make it the device as similar as possible, and also the connection must be same as what was designed in the schematics, right? So that's our intention. Yeah, matching is very important because, as we know, in manufacturing level, so when the foundry manufactures this, let's say it's a chip or IC device, so there will be a random kind of like random process where there will be a slight change in the oxide concentrations, or maybe slight change in the process manufacturing, like the photolithography, etching, and so on and so forth. So in order to minimize that kind of uh, process defect, so we need to make it as matching as possible, as match as possible. So how we do that? So there are several ways. So like this thing is actually a common centroid matching, we call it. So common centroid means I put the reference circuit. So this is the reference circuit, this one. So you see the reference circuit, you can see this is this being highlighted is actually the reference circuit when I click here. So the rule of thumb is the reference should be uh, at the middle of the block here. So this is the reference circuit, and it must be at the middle. Why? Because it must be surrounded, or it must be guarded by the the other devices. Okay, the neighboring devices, and this is actually the dummy. Yeah? Dummy must be at the edge or at the side of the block, right? So the intention of the dummy is to protect the devices, because this dummy will be act like a will sacrifice itself to protect this inside main device. So dummy will be yeah, just protect, I could say, to protect the block and also the transistors, because in process level, manufacturing level, you have what's so called the etching process. So the etching process will kind of like damage this main transistor. So we want to avoid that, so that's why we put this at the side. And maybe you are asking why we are not putting it at top and bottom. Actually, the etching effect will is actually not very much at the top and bottom, so it will affect the edge or the side of the device more than the top and bottom, right? And yeah, this is the dummy. And next one is actually we have this is actually the current mirror pair we call. This is the current mirror. So this is the reference, and this transistor will copy this reference current. That's why we call current mirror. So you can see here this and this, okay, and this. So you can see there must be a symmetry. When I click the next transistor, so it's here, right? So it's like the mirror image of themselves. Okay, there. So you cannot arrange this block randomly. What I mean by randomly is you cannot just put it everywhere you want. No, you need to follow certain rule. We call it matching rule and also layout rule. Uh, BRC, okay, the design rule check. So we need to follow that rule, and you cannot just put the transistor everywhere, because of course this will be affected by the manufacturing process, and we want to minimize that process defects. So that's why we do the matching, right? And as you can see here, the arrangement is like the mirror of each other. So this device, and this device is this device. They are the same mirror image themselves. Why? Because that to ensure that the center is always at the middle. So when you find the center of gravity of all the transistor, all of them masses will be concentrated here at the middle. It will be concentrated at the reference transistor here. Right, so you can try to do the math. Okay, you find the center of gravity, this, all of them, and you will find out that the mass or the weight will be concentrated here. Right, that's the essence of common centroid. So that's with this transistors. So this is actually common centroid matching. Right, so you can check that the center is at the middle, right? Common centroid. And this one is actually I think this is the current mirror at the bottom. So it's quite more complicated than the previous. And this is the inverter. So we have 4 inverters here. Yeah, so this one is the middle one, is the inverter. 1, 2, 3, 4. We have 4 inverters, and this one is the layout, right? So you can see the inverter is actually just the consists of the PMOS and also the NMOS at the bottom, right? And we connect the gate like that. So that's the inverter, and this is the enabler circuit, yeah, to allow the circuit to operate. So we call it enabler. So at the side here, you can see this one is the enabler of this block, or at this section, you can say. and this one is the enabler of the second current mirror pair, right? Yeah. So yeah, I've completed my checkup to make sure that all of the drain and source gates are connected well. So yeah, cheers.